Hello, we are going to start section 4.1 for Math 68, Introduction to Hypothesis Testing. In hypothesis testing, what we're really doing is we're using a statistical test from, again, a sample to assess a claim about a population. Remember, that's always our ultimate goal, is to use sample data and to then go back and utilize that sample data to say something. And a statistical test is framed always in the term of the hypotheses. We never talk about the framing of the experiment or the results of the experiment in a matter of anything but the population. Okay, and there was two competing hypotheses, and one of those hypotheses is called H sub O, H sub S-U-B-O, and this is a claim that there's absolutely no effect and no difference. Nothing is going on. Everything is status quo. If we're talking about the average amount of money made, we're talking about something that is just the normalcy. Now, the alternative, though, when we go to the alternative, and I want to change my color here, so give me a second. The alternative, H of A, it says that we're seeking evidence for this thing. We want to know that something competes with the statement H sub O. These two things are competing statements with each other. And we'll see how that works as we progress on here. So H sub O is the null. The null. Null means nothing, empty. And the H sub A is the alternative. The alternative means something. It says the alternative hypothesis is established by observing evidence. This is going to be the data that we collect, the statistics that contradict, and that's going to be a big term for us, contradict the null hypothesis and support the alternative. That is always our goal. We go into this statement saying, you know what, the null is supposedly true unless I can support the alternative. Think of it as innocent unless proven guilty. Okay? The hypotheses are always about the population parameters. Remember those population parameters? Mu for an average mean, p-value for a proportion, and that great looking rho value. When we have the statistical hypotheses, it formulates all possibilities, everything that can possibly happen. When we look at a H sub O, a statement about the population, it always, or usually, and I'm going to say almost 100%, uses equality. We're going to see an equal sign inside of our statistical values. I'm going to change my color, see if I can get something that's a little more alternating from where we are. The H sub A, or the alternative, was always going to include something about greater, less, or not equal to. These are going to be the left, the right, or the two-tail test. So when we refer back to, hey, how did you know it was a left tail meeting? How'd you know it was a right tail? Well, I looked at the symbol. Is it less? Is it greater than? Is it equal? Is it not equal? What is it? And we'll get these from the reference of the question. So here's your logic. One, state H sub O and H sub A. So we'll go in and we'll find out what's not normal and what is normal. We'll think of what the null model looks like. The null model meaning all the data being centered around the null hypotheses. And then think of what sampling distribution or what p-hat value would surprise you. Well, surprise you means falling outside of the curve. Falls outside of the curve. Remember, 95% population curve. We should see 95% of data fall within 2 standard deviations of our curve. It says in 2000, 30% of people like butter. Okay. So has it increased? State the hypotheses. Well, first of all, in H sub O, P, and I know it's P. How do you know it's P? Because it's 30%. So P would equal 0.3, never 30%, always decimal value of 30%. What does H sub A say? Okay, well, it's either less, it's greater, or it's not equal. Well, it says right here, increase. We're seeking evidence for something increasing. So our H sub A is P wants to be greater than 0.3. It says the null model will center at the null hypotheses. Okay, well, what that means for us, and I'm going to draw a little higher here, is that on the centering curve, the middle of that null will be 0.3. We always center at the null. What will surprise you? Okay, well, let's talk about what will not surprise me first, okay? What will not surprise me is a p-hat value right here, and a p-hat value right here, and a p-hat value. All of these p-hat values will not surprise me. Why? Because they're inside of the two standard deviations that we have talked about, or one measurement of error. So what will surprise me? Well, what will surprise me, or what I will seek evidence for, is something extreme outside. Something extreme outside. And actually, I'm not going to include this other one because, remember, it talked about things which increase. So something to the left would not surprise me. Matter of fact, I wouldn't give me evidence at all if I got something on the left. I'm looking for something from this point here this way. And the farther it gets to the right, the more shocked I become. Use that term shocked loosely, okay? It says determine whether the set of hypotheses given are valid hypotheses or not. All right, well, let's look down through these. First of all, I'm going to give you a way to eliminate a whole bunch of these. First ones, and I'm going to change over to red because red is bad for this. I'm going to look for anything in the null hypotheses, the H sub O, that does not have an equal sign, and I am going to get rid of it. First one, gone, because of not equal in H sub O. H sub O in letter C, I'm going to get rid of it. Less than, can't have it. I'm going to circle that. Can't have that. Can't have that. I'm going to look for something else down here. Not equal sign right there. Going to get rid of that whole line right there. Now I'm going to go back and I'm going to start going through these. I'm going to start looking for, okay, which one doesn't talk about a population parameter? I'm going to get rid of all of those. All right. So I'm going to come down. First one, A, it's a mu. Okay. D, see letter D? See the not the parameter, but the statistic, gone. I'm going to come down through. P-hat, gone. Don't even need to look at it. Okay, now let's go back up through and let's see which ones are good and which ones are bad. Now that we've eliminated the majority of them. Very top one, H sub O. I want you to have mu equal, good, versus H sub A, not equal. Perfectly valid. Go down to letter E. Rho is allowed. You're allowed to be equal to 0. Fine. And you're allowed to be less than 0. Fine. Valid. We're going to go down to letter G. I have a value in G. And what do you notice about, first of all, it's a proportion, so that's okay. Good. Proportion. However, though, remember, proportions inclusively are between 0 and 1.0. 0 and 1.0, from 0 to 100%. This thing says you are at 250%. Nope, can't do it. And then I go down to the last one, I. And I says I want you to take mu1 minus mu2 and have it equal to 0. That's fine. And I want you to take this alternative mu1 minus mu2 and I want you to be greater than 0. Absolutely valid. It says sleep versus caffeine. So it says students were assigned words to memorize and they were randomly assigned to take either a 90-minute nap or a caffeine pill. Okay? That statement right there, they were assigned to do something. That is our explanatory value. So a 90-minute nap or a caffeine pill. That is what you are being explained in your explanatory. What is the response? Well, the response is going to be the word recall. How many words did you recall when you did this? Well, first of all, I noticed something right away. One, this is quantitative, or excuse me, this is a category. I almost wrote my category in the wrong place. And this is quantitative. We have a categorical quantitatives issue. Why do I need to know that? Well, I got to go down here and I have to pick out what to do. You can't have a proportion when you're talking about categorical and quantitative. You can have a mean, but we need the difference in means. So this mean is singular. This mean is two means. We're going to take mean 1 minus mean 2. If you have two groups and you're measuring a quantitative value, it's always going to be the difference in means. Always. The next question says, let mu of S and mu of C be the mean number of after sleeping after caffeine. So we have sleep S, caffeine C. Is there a difference in average word recall? Difference does not say more. Difference does not say less. Difference just says difference. This is a two-tail test. We're going to talk more two-tail stuff here soon. So the question is, what are the null and alternative? Okay, well, first of all, remember, not equal, those are gone. So it's either B, it's either D, or it's either E. All right, well, then let's look at the alternatives. In the D and E, the alternatives have greater and less than symbols. Can't have those. B is the only one that looks for me to have equality and not equality. And also, notice that this leads to this algebraically, which also leads to this algebraically. This statement here is a much more preferred statement than the one given in letter B. We have a Wiley question, and it says, indicate if the analysis involves a statistical test. If yes, state the population parameters of interest. All right. We're testing 90 people in a driving simulator to find the average reaction time to hit the brakes when the object is seen in the view ahead. Well, first of all, there's no explanatory here. There's no sleep deprivation. There's no having them text on their phone. There's no measurement. So in this first one, this one would be marked not a statistical test. You have no explanatory variable which you are measuring to see if there is a difference between two measurements. The next one, giving Coke and Pepsi taste tests to random people in New York to determine if there is evidence for the claim. Okay, so I walk up to the booth, I pick Coke. I walk up to the booth, I pick Pepsi. That's a statistical test because I am put into a category immediately of which one I'm going to choose. So my value here is not an average because they're not measuring how many pops I drink. They're measuring if I chose a pop or not and how many people choose that kind of pop. So my H sub O would be that the amount of people who prefer Pepsi is 0.5. That means nothing's going on. Half the people like Pepsi, half the people like Coke. And then in the second one, H sub A, and I should have put colon here, sorry. Well, now remember, I'm seeking evidence for the claim that Pepsi is preferred. In other words, more of. I want Pepsi values or Pepsi proportions to be greater than 1/2. The higher that proportion becomes, the more evidence I have gathered that says Pepsi is really preferred compared to nothing going on. In the last one, testing 400 right-handed participants on the reaction time. That's going to be an average number, right? The average number of reaction for their left hand and their right hand to determine if there is evidence for the claim that the right hand reacts faster. So that number is going to be smaller. A faster reaction is a lesser number. For this question, define U of R, that's average of right hand, to be their right and for U of L to be the average of their left hand. Okay, so how about H sub O? This is definitely a test, and this H sub O value will be that the average for the right is equal to the average for the left. If absolutely nothing is happening, the two times are equal. Well, that means H of A that now remember, we want the right hand to be faster. So U of R is going to be less than U of L. We're not measuring where quantity is better. We're measuring where having that number will be better because it's smaller. Indicate if the analysis evolves. So same question, and do we have a population parameter? Polling 800 people in a large community to determine if there's evidence for the claim that the percentage of people in the community living in a mobile home is greater than 14%. Well, it doesn't say a sample of the community. It says polling 800 people in a community. And if I look at this, I have to be careful on a question like this, whether it's all the people involved or whether it's some of the people involved. So we're going to have to, so first of all, there's no word all in here, okay? So I'm looking for a word all and I'm reading it twice and don't see the word all. So if I saw the word all right away, I would say, nope, this is not a good statistical test. I'm polling 800 people in a large community. So I have to take an assumption that says these 800 people out of this large community, that this is a sample. Okay, if I have any indication at all that it's all of them, then I can't do anything with this test at all. So it says, first of all, let's look at H sub O. We want H sub O to be equal to 14%, and 14% is never an average. It's always a proportion. So I'm looking for proportional values, and I want it to be greater. My alternate statement wants to be greater. So I'm focusing right away on this proportion here, and I'm also focusing on this proportion here. I'm not focusing on these because those are average mu values. Well, if you look at the alternative, the first one that I have underlined has a greater than 14% for the average, so I have to go with this value. Again, I would use this if I saw the word all people polled. Wiley does sometimes add that word all into there, and you have to be careful of that, okay? If it says all, then it's not a statistical test because you asked everybody in the community. Here you go. I guess got my answer for me. Utilizing the census of a community, which includes the information about all residents. See it right there? That's what I was looking for in the last one. The minute you see all residents, you don't have a statistical test, okay? Because you just went and asked everybody. You don't need to do a statistical test. You know the answer because everybody answered it. It says a statistical test is conducted to see if there is evidence that the proportion of U.S. citizens who can name the capital city of Canada is greater than 75%. This is what we are seeking evidence for. Okay? Use the following possible results. Okay, so first of all, if I took the first number, 38, and I divided it by 40, again, 38 divided by 40, I would get 0.95. And if I did the next one, I would get 0.775. If I did the next, I would get 0.85. I'm doing these kind of fast. I hope I'm getting these right. And 0.675. State which of the possible examples provides the most significant evidence. Okay, well, first of all, it was greater. That's what we're seeking evidence for. We're looking for the number. I'm going to draw a little curve here. Ready? A little curve here. Right in the middle of it is 0.75 because remember the null hypothesis, nothing going on, is where the center is. I want greater. I want the number that is as big as possible past 0.75. I do not want anything over here because that would provide absolutely no evidence at all because it's the wrong direction. So 0.75, so first of all, if I look, okay, this one's a little bit away. This one's a little bit further away. This one is really further away, and this one's the wrong direction. So the one I want to look for is sample A. State which, if any, of these possibilities results in no evidence. Well, I already made that statement, and it's D and D because it went the wrong direction. A summary: statistical tests use data from a sample to assess a claim about a population. Keyword blue right there, population, and it uses a statistical test. Statistical tests are usually formalized with competing hypotheses, H sub O versus H sub A. The null hypotheses, no effect, no difference, nothing going on, status quo, everything is good in life. Alternative hypotheses, we seek evidence for this, okay? If data are statistically significant, that's a word that means really unexpected, outside the curve, really far away from the middle. We have convincing. We don't have proof. What we have is convincing evidence against the null, okay? Against the null. We will not say for sure. We will not say that this is the way it is. We will say, I have evidence to sway you away from H sub O, and that's all we will say.